So, welcome all. This is our idea for sorting machine as group E's. This is our idea one, a coin sorting machine. We use the coin sorting machine mechanism of how the coin drops in the sorting machine as the shape of the coin is different for all. As you can see from the sketches, the smaller coin will go down first while the big coin will roll over the hole and go to the biggest hole. And the slide must be tilted, because if the coin slide is not tilted, it won't fall in, it will fall the other way around. And the biggest issue with this is also that the coin must be flat or it will just get jammed. So as you can see from the next slide, the place horizontally may able to fall and may not fall back. So we were thinking how we could improve it, and when placed vertically, yes, it may have a higher chance of falling in. So the problem one to be able to sort the holes out, making of a way, of a solution. So as you can see from the next slide, coin sorting machine mechanism is, as I sketched the whole thing out. First, the machine will drop down, and the spoon utensils will go down first, while the plate will go down next. But the problem is, this one only can sort out spoons and plates. And side note, the machine will have a vibration function, so it will have more movement, one could say. So now, Wen Xuan will be appearing to my left side right about now.
Explain idea 2, which is magnetic crane and conveyor belt. Conveyor belt is an object that is used to move things around using two sets of pulleys, which you can see it goes, it can go up or down, doesn't matter regarding the direction. Next we have the magnet, which is the magnetic crane in the title. As you can see, these are all metallic objects. And this is what we call an electromagnet, which is toggleable. You can turn it on, you can turn it off. Next slide. Okay, so for our idea 2's illustrations, we have the conveyor belt, which is over here. As you can see, the pulleys are over here. Regardless of direction, it can go left or right, doesn't matter. Now on the conveyor belt, pardon me. On the conveyor belt, we have the utensils, the bowls, and the plates. This is just an illustration, it's not the real items that we are using. Now the problem is only the utensils will be sorted out. Why? Because it's the only objects that are metallic. For example, bowl and plate, they are not metallic, they are maybe ceramic, they may be glass, but ultimately the problem is only the utensil will be sorted out, and we might need to think for a better improvement. Next slide. Now, this is an illustration of how we predict our idea 2 is going to go. As you can see, there is a moving electromagnet which picks up all the metallic utensils. Meanwhile, we have the conveyor belt, which is moving along, pushing the plates and bowls to the other side. From the top view over here, we can see that there are two magnets to have a better control of getting a utensil, because as you can see from this top view, it's not very efficient, but when you see it from the top, you can kind of guess how it looks, because there are two over here. Both magnets are going left and right, which will give a better range for them to suck up the metallic utensils. Next slide. And so this is our idea. The utensil is attracted to the magnet as seen from the illustration. The plate and utensils, at first they are being transported down the metallic crane using these conveyor belts. And then after 10 minutes, the crane and the tray section will move the belt while the others will do the opposite, as you can see. So to give a clear illustration, plate bowl spoon here, metallic spoon go up, metallic spoon go there, drop down because it's an electromagnet, it's a toggleable. As you can see, the utensil is then dropped into the tray as the magnet will turn off. So this is a toggleable electromagnet. Okay. Now I'll pass my time to Sakil for idea 3.
Sorry. Okay, thank you, Xuan. So I'm going to explain my idea, which is idea 3. It's high sorter. So actually, this idea what I thought was, as you know, bowls, plates, and spoons at different heights. So what I thought was, this is like a stopper to stop the bowls with the height. Then the plates and the spoons will go through the gap. Okay. So as you can see, so the idea was, as you can see, the bowls will, like, this is the stopper, so the bowls will get stuck with the stopper, so the bowls will move with the stopper, like just move around, and then there is a container here to drop in the container. Because this one happening, what it did is was having the gravity, so once it's like a slide, so once it slides, there is a gap, then with the gap, the plates and the spoons will go through it. Okay, so this morphological chart, so there's 3 ideas we had. The first idea was coin sorting machine. The idea was good, but then the spoon separation was a bit hard, what you thought. The second idea was magnetic crane and conveyor belt, which was a good idea. We can separate the bowls, spoons, and the plates, but the problem was the kit we were given was a plastic, so we couldn't use the magnet, as the spoon we were given is a plastic. So the third idea was high sorter machine. As for my idea, as I said, it's a sliding. But the problem was with this was the place and as a kit we were given the place and the spoons, the height was kind of same, so it will be going together. So we had to create a different idea to use the kit to do different. The first and the third idea we combined together and created this machine. So next. Okay, so the part 1, what we did was, this was the shape, like this was the kind of like high sorting, but we used the shape of the bowls and we cut the holes on a box. So these holes, what we do is we separate the plates from the bowls and spoons. So basically, the spoons and bowls will go through the holes, and the plates will remain in the box. And there is a movement for the box, which what we had 3 ideas for the movements, which is vertical movement, horizontal movement, and oscillation movement. So what we took as the oscillation, like swinging like this. So it helps the spoons and the bowls to go inside the holes. Okay, so that was the first part. So the second part was how to separate the bowls and the spoons. So what we did was use the same height idea, the high sorting idea. So we separate the bowls with the height. So basically we put a stopper here on the slide, so the bowls will stop and the spoon will just go down through the gap, and there's a container here for the spoons to drop. Okay, so this is the first idea, which was so now we must separate the spoons. How we separate the spoon was we must separate the plates. The plates will remain in the box. So after the bowls and the spoons separate itself, then we're going to separate the plates. So what we do was we topple the box itself, and there's a gate at the bottom which will open up for the plates to drop, and just slide down, and then the container here for the plates. So how we how we open the gate, we use Arduino coding. So to open the gate and close the gate, and to move the box like in the oscillation motion, we use the Arduino coding for it.
It took actually more than 2 weeks, 5 weeks. So we made the top part, which was 3D printed, and the bottom part for the cone. And the base, we had to shave off some part as the bowls would keep getting stuck and spoons would not drop. So we had to shave it down and make the height of the base a bit higher. So here's the coding of for the machine. And I'm gonna do the wiring, I guess, in a brighter place. So there you go, the product's here. And the motors, boom, they're all here. Look at that precious, that's hot. There's the motor. Back, section. Bam. Well done. Well done. Eureka, we actually did it. Look at that, it's more cleaner now. Look at that, the box opens like a beast. Look at that, it moves. Ooh. It works.
Like a charm, like a glove. Like a glove.
Wait. Now the big question is, will it flip over? Shit.
Be a 5 times, stand by, drop together, start. Alright, one more time, so deep.
Okay, fine.
Stand by.
Again now.
Yeah, 5 times for this. Stand by, start.
Yeah, every time I go pick, I can one time. At least I get 2 pair.
You went the wrong beam. I'll take an intervene. By, start.
Oh no. This is confusing me even more.
Stand by, start.
Listen here.
Stand by, start.
Stop. It's like music. I like the door. My door is the favorite. For some reason.
Start. Okay, stand by, start.
Wait, I missed that. Okay. Press it, it got stuck there.
Wait, 3 more. Stand by, start.
It's not working. It's clearly not working.
Penalized by the one, so I get by. It's okay, yeah, 3. Stand by, start.
Emotional.
Where's the ball?
Finish it off.
Also,
Stand by, start.
you need to use force to it. How?
So I take it.
Team was not able to successfully complete our test run. And I also apologize for not being able to finish our product in time, which is why we failed.
Doesn't even work. Kid, look, it died.
And I would like to apologize
Sakil.
to my teammate who was AFK here, letting him down, and Also, the glue guns. I had to apologize for so many things.
Oh man.
Anyways, that's about it. Logan.
I'm replacement Sakil.
Sakil replacement.
Yes.
How did the product go?
First you put the thing inside
Hey!
and then you do, and then it doesn't work. So as you can see, nothing works. Yeah, nothing. I don't know where the ball went. Gone.
Prove that. And tell us what's wrong with it, okay, Sakil?
So as you can see, it's already not working. Two of the plates got stuck. This is in the wrong place. This flew out the side, went to God knows
tell me
where.
what's wrong with this.
Okay, so the main issues that me, Sakil, am facing is this isn't working properly.
So
This isn't working properly.
why is the door not working, Sakil?
We didn't make it properly. The RAM also does not work properly, so... Where did that come from? Essentially nothing works.
Except the coding. It like half works.
Kind of.
Kind of. So how do we approve this?
So what we are planning on doing is failing this module. What we will be doing is we'll be redoing everything.
Where the hell is this coming from?
Let's keep...
Let's see again. Let's show.
Maybe...
As you can see, spoons are getting stuck on the door
the plates are getting stuck in this stupid thing.
because the holes are. How small are the holes? Really small.
The holes are...
Rough.
yeah.
Rough. And because we have plates that are freaking sea salt, like they are cutting out mouth.
I don't know, like this is definitely not like the standard IKEA collection of the plates.
And as you can clearly see, the bottom part is working, the top part is shit. Where the bottom part sort of working? Sort of. 50-50.
Yeah, this just doesn't work.
I'm gonna put some dirt in your eye.
Top part is terrible. Tell me you got stuck again. Wow!
Hey, look, it worked.
We got it on camera.
As you see, it is a very reliable machine.
Very reliable, very
So we
reliable.
are only asking for a small investment of $3.8 million to put these out in the canteen.
Prototypes.
Yeah.
Are we on Shark Tanks right now?
Yes. For a 20% share in my company, I asked for 18 million. If you look on this side, we like to call this the fire hazard side. It involves a lot of short-circuiting wires, and the servos are mounted very professionally.
Oh, motors that died for this.
Collateral
freaking
damage.
360 motor.
Yeah.
Collateral damage. Look at that. This motor died for a reason. Boom. 360. Then after that, right 90, then it goes to 90 degrees. After that, that's it. I need to delay for now.
Okay. Hang on. There is no more gap. Nice.
Yeah, when you come here, when you put that to make sure. This part doesn't like to push a bit lah, so it's like that. Okay, it's more easy. Get start. Okay, I think I'm gonna do this part. But the problem is the gap here now. This gap I have to close. This gap I have to close.
I mean, gate looks trash.
The gate looks trash. So we change the base to this. This is the top. This is the bottom. From this to this. So things can be sorted out. There's supposed to be a hole here, but yes.
Let our powers combine. Earth, fire,
Wind, water,
by your powers combined, I am Captain Planet.
I just got bitten by my own machine.